Okay, day 4, quadratic equations. So today we're looking at the quadratic equation and different ways it is represented. So we're going to start with the most basic, the parabola. So guys, this shape, the parabola, is what you get when you graph a quadratic equation. When you graph a quadratic equation, you're going to get this shape. Now, it could vary, it could change in size, direction, but you get this kind of U shape, okay? Now, the original, the parent function is this. This is the parent function, x squared. Anytime you see x squared, you have a quadratic. If you plug in numbers, -2, you get 4. -1, you get 1. Plug in 0, 0, 1, 1, 2, 4. So if I made a table using this, I would get these points, and you get a graph like this. Okay? Now, this is the original. This is what they are all coming from. So, what are some changes to this parabola? Well, what if you take the function and you multiply something to it? So let's say you take a number and you multiply x squared by 5 or 10 or 1/5 or -4. Well, if you multiply a positive number, it stays the same shape. But if you multiply a negative number, it flips upside down. So -5, -10, -1/2, -3/4, all of a sudden the U shape is now upside down. Okay? Another thing, if you multiply by a big number, let's say you multiply it by a whole number, like 2, 5, 10, 12, 15, 20, what happens is the U shape kind of gets compressed. And the bigger the number, actually the closer it gets to the y-axis. But if you multiply it by a fraction, like 1/2 or 3/4, or a decimal like 0.2, then actually you get it wider. You would get a wider shape. Okay? And the same thing happens when it's negative. When it's negative, if you multiply it by -3, -10, -20, -100, it would get compressed. It gets closer to the y-axis. But if you multiply it by a negative fraction or a negative decimal, it gets wider. So that's one way to alter the shape of it. Another way to change it is to change the center. Now, the center point for all of these has all been in the same place at 0, 0. All of them have the center at 0, 0. We call this the vertex. The vertex for all of these is at 0, 0. But you can change that point. If you change the vertex, you can move where the center is and move the parabola. Now, in the equation, you have to use two numbers, though. Those two numbers will give you the new vertex. It'll give you the new center point. Okay? So now you can change the size, but you can also change the location of the parabola. So that's how we come across vertex form. In vertex form, you have this gives you the direction that it's going, and these two numbers will give you the vertex or the center of the graph. Now, if you notice, h and k, h is the x direction, so on here, h is represented on the x-axis, and k is represented on the y-axis. So in this case, I have a -k. So the number I plug in here is negative, but the number I would plug in here is positive. It's different over here. The h is a negative number, so I'd plug in a negative number here, but the k is a positive. So it's very important to know if you have a negative h or or a positive h, or a negative k or a positive k. That changes where you're going to move the parabola. So let's do some examples. So right here, this is a positive number. So this tells me it will go up, so it'll go upwards like a U, like a happy face. Okay, that's what that tells me. It'll go like that. And this is my h and my k. Now, if I take these numbers, h is 2 and k is 4. So my vertex is at 2, 4. 1, 2, 1, 2, 3, 4. Now, the reason it's not a -2, the formula has a negative sign. I am not changing the negative sign. I'm asking you what was plugged in for h. What number did they plug in for h? They plugged in a 2. They did not plug in the negative sign because the negative sign was already there. Okay, now what about graphing the rest of it? We know it's going to go up, but if you want to know exactly how it's going to go up, what you need to do is make a table. You need to make a table where 2 and 4 are in the middle, okay? You need to make a table where 2 and 4 are in the middle. Now, because this is the middle, the numbers next to it need to be the numbers next to the number 2. So what numbers are next to the number 2? 1 and 3. Now maybe another one, 0 and 4. That's how you should make your table. At least 5 points. And you already have the point in the middle, so all you have to do is find these other points, okay? So to graph it more accurately, I'm going to plug in this number into the function, okay? Now, here's what you should do. Open the calculator app on Desmos. So I'm going to go to Desmos Scientific. All right. Now what I'm going to do is I'm going to type in this equation. Now, 3 parentheses, I'm going to leave that blank, minus 2, close parentheses, squared, plus 4. Okay, so you already have the middle number. You know that if you plug in the 2, what do you get? You get 4. What else are you going to plug in though? Oh, let's plug in 1. Okay, I get 7. Okay, let's plug in 0. I get 16. Okay, let's plug in 3 now, because I haven't done those. 3, I get 7. And 4, I get 16. Now, if you noticed, the answers repeat. You see that? 7 and 7, 16 and 16. Now, that should always happen. When you graph, the points on both sides are reflected. The point over here is the same distance over here. You have the same value for y. And then when you get to 16 up here, you get the same thing up here. So that you keep the U shape. Because if they're different numbers, it will get kind of like, it won't stay a U shape. You might get like a straight line, or you might get a curve that goes the other way. To keep this parabola the right shape, these numbers have to match the numbers alongside it. Okay? So, that's how you want to graph it. Let's do one more. Okay, here. -6, so I know it's a negative, so it's going to go down. I know that. Okay? Now, my h, the sign changed. They changed the sign. The only way to make a negative positive is by plugging in another negative. 2 negatives turns that into a positive. So -2 is h, -4 is k. Here's my vertex. -2, 1, 2, 3, 4. There's my vertex, and it's going to go down. Now again, I'm going to make a table where the points in the middle are -2 and -4. And I want the points next to it. I want -1, I want 0, I want -3, and I want -4. Now here's now that you know the points reflect, when you use a calculator for this, okay? So let me go back, bring out the calculator. I'll plug in a -6 over here, so -6. Get rid of this number, plus 2, and a -4. Sorry, -4. There you go. Okay, we already know what happens if I plug in a -2. When I plug in -2, I get -4. If I plug in -1, I get -10. Now, what you should remember is, wait, the numbers reflect. So if I plug in a -3, I would also get -10. And if I plug in 0, I get -28. And that means down here, I should also get -28. And if you still don't believe me, we'll plug it in. But you get the same numbers. So when you graph it, you're going to be more accurate with it. So -10 on this side, -10 on this side. And then -28, which is going to be even lower, actually way lower, -28, it's going to keep going down. So you would get a parabola that goes like this. Now, of course, in your graph, if you had an answer for this, you wouldn't need all those points. You can just graph this, and we understand what's happening. We understand that if you put arrows right here, what are we saying? the parabola is going to keep decreasing. And you're good. You wouldn't need to put the other points. So if you have a limited graph, graph the points that you have and just put arrows and you're fine. And that's how you would graph it in Vertex Form.